Hey guys, video 7. You're going to learn a lot more. Some of this may be a tad confusing, but we're going to go over the calculation and the formula, which I do want you to know. But just some of this stuff may be like, what's he talking about? You'll know exactly when you get here. But let's chat just for a second about yeast cell counting, the skill that you have to be able to know how to do, which is one of the main reasons we're teaching you how to use a microscope for yeast cell counting. So it's an extremely important skill, one, to be able to use a microscope, and then one, identify the yeast cells and be able to count those and figure out using this formula, which is easy, to figure out how many yeast cells that you have. Do you have enough for your beer to make a good quality beer? So we're gonna go to the board in just a second. However, I'm gonna show you this grid that looks crazy, but this grid is what is on your hemocytometer slide that we looked at that you really can't see because it is etched in laser-wise and it's microscopic. But these grids, or this grid, is on this hemocytometer, and really all this grid is for is to help you keep up with the cells so you can count them properly. If you didn't have a grid on here and you just had a blank screen, if you will, or a blank slide, and you've got literally hundreds and hundreds of cells that you're trying to count, you can't keep up with those cells where they are. So we use a grid and a hemocytometer. That's the sole purpose of a hemocytometer, is to keep up with the cells that you're counting so you can do a proper and good count. So eventually we're going to get this into focus, and these yeast cells are going to be all over this grid, and eventually we're going to find this center square. So you can see this big pattern here, and these colors will not be on a real slide. This is just sort of for teaching purposes. But this center square, which has 5 times 5, 25 larger squares or smaller squares inside that square. And each one of these squares has 16 squares in it. So all these squares are so you can keep up with the cells. But I've got 5 of these 5 squares circled for a reason, because when we count our cells under the microscope that we're trying to keep up with and do our total yeast cell count, these 5 squares are the squares, the areas that we're going to be counting the yeast cells in, and it'll make sense here on our formula. So we're going to count the cells in our upper left square, upper right square, lower right square, lower left square, and the middle square. So we're going to count the cells in those 5 cells. Then we're going to multiply that times 5 in a second so we can get all the cells that are in that big square. Okay, but I also wanted to show you this. Let's look at our formula. So let's do our overall formula, and we'll explain what the formula is. So yeast cell counting, hemocytometer, there it is spelled out. That's our fancy slide that we're going to use to count the cells. So yeast cell counting is number of cells in the 5 squares that I just showed you. Okay, that's one factor. All right, then we're going to take that, multiply that times 5. Okay, 5 is our constant because we multiply times 5 because there's 25 squares in that big square. So we're going to count them all, but we're only counting 5 of the squares. So we're going to count the number of cells in 5 squares. So let's say it was 21 in one of them, 22 in the other one, 31 in another one, 28 in one, and then 19 in the other. 1, 2, 3, 4, 5. We add these up, multiply that times 5, okay? Then we're going to multiply that times the DF. Let's put this down here. DF equals dilution factor. We'll talk about that in just a second. But again, when you come here, we'll talk in more detail and make probably much more sense. So DF, we're going to multiply the 5 squares that we counted the individual cells in, multiply that times 5, multiply that then times the DF, and we'll talk about what the DF is in just a second. We're going to multiply this times another constant, 10,000. Okay? And that's going to equal total number of yeast cells. That's the number we're wanting. Okay? Number of cells that we count, add those up, multiply that times 5, multiply that times our dilution factor, multiply this times 10,000. That's the scale of our grid. It's on a hematometer. I mean, you can get a handout and see where that 10,000 number comes from. That's a constant. Dilution factor is how many times, let me write that so you can read it. How many times, or how did we dilute the yeast cell sample that we have taken? So we've taken a sample of yeast out of our fermenter or wherever we're counting it from, and we usually have to dilute that down. So if we have no dilution, if we didn't dilute it at all, we just took that sample, didn't dilute it, so that dilution factor is 1. DF equals 1. We just didn't dilute it at all. If we diluted it, and we dilute it by a factor of 10 every time, again, we'll go into this. If we dilute it to a 1 to 10 dilution, then a dilution factor is 10. And we would have put 10 here if we diluted it once. So we always dilute it by a factor of 10, and we'll talk about how we do that. We're not going to worry about it right now. If we had diluted, our original sample a second time, that means we diluted it another factor of 10. So that's now 1 in 100 dilution factor. And the DF then would have been 100 if we diluted it twice. Take our sample, dilute it by 10 one time, wasn't diluted enough, dilute it again, it would be 1 in 100. If we had diluted yet a third time, as you can see, we're just going by a factor of 10, then our dilution factor would be 1,000, and we would have put 1,000 in there. Okay? So if we didn't dilute it at all, 1 is there. Number of cells times 5 times 1 times 10,000 to get our number. If we diluted it once, it means it's a factor of 10. We would have put 10 here and multiplied that out. If we diluted it a second time to 1 in 100, then our dilution factor would have been 100. And if we did it a third time, which probably you won't, but you could, factor is 1,000. And so these numbers are going to be in the millions. A lot of cells per cubic milliliters have what the cells are. That's a lot of cells. But anyway, I want you to know this formula. So, if I give you a problem, you would have counted these cells. I'm going to say, here's the number of cells you've counted. You diluted it twice to 1 to 100. Now figure out our number of cells. Add these cells up. Multiply that times 5, which is a constant. Line it in orange. Multiply it times our dilution factor, whatever that was. In this case, let's say it's 1,000, diluted it 3 times. Then multiply all that times 10,000. That's our other constant. This stays the same, this stays the same. These two are going to vary depending on how many cells you count and what your dilution factor is. I want you to be able to do that. So I would give you these cells that you counted and then your dilution factor, and boom. So you need to memorize this formula. This is the only formula that you're going to have to memorize. All right, see you.